Welcome back, everybody. In this video, I'm going to talk about one-to-one functions. Now, to determine if a function has an inverse, we must show that it is a one-to-one function using a method called the horizontal line test. Now, what that means is that if we plot a graph, like the examples show in front of us, and if we draw a horizontal line through it at anywhere, and if it appears that the line crosses the graph at more than one point, then the graph has no inverse and therefore is not a one-to-one function. So if we begin with the example here, if we apply a horizontal line test somewhere here, let's say, we can see that the line only crosses the graph at one point. And if you do this technique pretty much anywhere, you can see that the line will still cross the graph only once. Now, if this thing occurs, then we can say that the function is one-to-one and therefore has an inverse function. If we look at the next example, we can see that we have a parabola. And if we apply the horizontal line test, excuse me, I don't know why I keep saying vertical line test. If we apply the horizontal line test right here, we can see that the line crosses a graph more than once. And immediately we can say that this is not a one-to-one function and therefore does not have an inverse. For our last example here, if we apply the horizontal line test, we can see that the line crosses the graph once, and this happens pretty much anywhere on the graph. Therefore, this function is one-to-one. Now, I'm gonna write an example here. Now let's say that we're asked to determine if a function is one-to-one, and we're given coordinate points 7, 3, 8, -5, oh, excuse me, 8, -5, and we have -2 and 11. We also have -6 and 4. And then in another example, we have -3, 8. We have -11, -8. We have 6 and 5. And we have 7 and 8. Now we're asked to determine whether the top function is one-to-one. A function is one-to-one if the y values in the ordered pairs are unique, which means that none of the numbers are repeated. And as you can see in the top function, we have 3, -5, 11, and 4. Since all the y values are unique, we can say that the function f is a one-to-one function, and therefore it must have an inverse. If we look at the next example, we can see that the y values are 8, -8, 5, and 8. Since 8 is repeated twice, we can immediately say that this is not one-to-one, and therefore it does not have an inverse. There's not a lot of math to it, really. You can determine if a function is one-to-one just by looking at the graph, as we did in the previous examples here. Or you can go ahead and take a look at the y values of the order pairs of whatever function really. And from there you can determine whether or not it is one-to-one, and from there you can determine if it has an inverse or not. Thank you for watching again. Please don't forget to hit that subscribe button, and please go ahead and like this video. If you have any questions or concerns, please leave a comment in the comment section below and I'll make sure to get to that. And we'll see you in the next video.